Hello, AP Environmental Science students. Welcome back to another review virtual lesson. My name is Dr. Sowell, and I teach APES down in Jacksonville, Florida at Darnell Cookman Middle High School. All right, so just a quick reminder of our exam date and times. And then remember, you can easily find the descriptions of the 2 FRQs on this year's exam. Remember, only 2 FRQs, no multiple choice. All right, so let's start with our warm-up, which is our homework from last night's session, or last session with Ms. Fassler. She talked about energy and looked at some fossil fuel usage and mining. So we're going to start with this question about fracking, hydraulic fracturing. So there's a little article about natural gas from rock, and then A, B, C, and D. So let's look at A. A says, identify and describe 2 water-related environmental problems associated with fracking. So we're looking at an identify and a describe. So there's 2 points for each of the 2 problems that you find. So the first one you could have put is something about the groundwater. So the chemicals or the waste from the fracking process leaking into the groundwater, or some of the actual natural gas, methane itself, leaking into the groundwater. Or you could have put those same or similar issues with surface water, some of those contamination of the wastewater getting into streams or lakes or ponds. And then finally, you could have put just the amount of water used. That's a lot of water that is being used during the fracking process. So we could kind of look at unsustainable over-withdrawal use of aquifers there. So all water related, groundwater, surface water, just too much. And that's worth 4 points, 2 for each of the identifies and 2 for the descriptions. All right, B, natural gas is considered to be a better fossil fuel for the environment than coal is. Discuss 2 environmental benefits of using natural gas as a fuel compared to using coal. So we're not looking for 2 environmental benefits in general, we're looking at 2 environmental benefits as compared to coal. And you could have said fewer SOx, NOx, mercury, carbon dioxide, those things that are emitted when you burn coal. Or you could have talked about the fact that the mining practices are less destructive. So mountaintop removal is clearly much more destructive to the habitat and into the environment than fracking is. Or you could have talked about soot, that particulate matter, or greenhouse gases, carbon dioxide. Here's an important part to this one. It says, in part B, some students did not fully describe the benefits of natural gas as compared with coal. For example, students said that natural gas emits fewer air pollutants than coal without identifying the specific pollutant. This is the commentary that some of the teachers and the readers provide after they've read the thousands and thousands of responses. So the advice to teachers based on these problems was remind students to provide specific information in their answers. Generalities like air pollution or pollution do not demonstrate the level of understanding expected of a student who has completed a college level course in environmental science. At this level, students should be able to specify types of pollutants like SOx, NOx, particulates, mercury, things like that. So again, remember, when someone is grading your FRQs, it's not what you meant that gets graded, it's what you wrote. So write like you've taken the course, be specific. C says, describe 2 environmental drawbacks not related to water use of using the fracking process to extract natural gas from shale. So any environmental drawback of fracking that's not related to water use. Always watch out for these clauses, because when we do grade the FRQs, a lot of times students will miss this and we'll see them talking about the kind of other than clause in the middle of a question. So you could have put something about habitat fragmentation from the drilling site, an increase in earthquakes, methane leaks into the atmosphere, causing an increase in greenhouse gases, all of the machines and tractors and drilling equipment that burn fossil fuels would release SOx, NOx, carbon oxides, and all of that stuff into the air. Noise pollution, that's kind of a cool one. Noise pollution from all of the drilling and the truck traffic. So lots of environmental consequences of fracking that are not related to water. And D says, describe 1 economic benefit to society of using fracking to extract natural gas from shale. So you could have put, we don't have to rely on foreign sources of oil so that foreign influences don't affect our price as much. Jobs, that's always a good option if it asks for an economic benefit, because a lot of the things we're talking about need to be built and maintained, and that is a source of jobs. And then finally, you could have put the individuals who lease their land to fracking companies can make some money there as well. All right, so that was the review from Ms. Fassler. Let's jump into what we're going through today. So our goal today is to discuss more of the renewable energy sources. So we're going to look at solar, hydroelectric, geothermal, hydrogen fuel cell, and wind energy. So this is the order that it goes in the curriculum, but I'm going to go a little bit out of this order. And then several times today, we are also going to focus on the science practice number 1, concept explanation. You know, you will have to do this at some point, probably on one of the FRQs, describing something and explaining something. So we'll practice that a few times. So the first thing, before we get into those sources, I just want to talk about electricity generation a little bit. So remember, electricity is the movement of electrons. So if we're going to make some electricity, we got to move some electrons. And one way to do that is with a generator, an electromagnetic generator. And in an electromagnetic generator, we have magnets and coils of wire rotating around each other. And that rotation causes that flow of electrons. So we take that mechanical energy from the rotation and turning that into electrical energy. Well, how do we get this to turn? Well, we typically put a turbine on it. And how do we get the turbine to move? We put something like wind or water or steam on it that will then turn the turbine, that will turn the generator, that will generate electricity. So I put that little picture up here to remind me to show you this. I went into my classroom the other day and got my little handheld generator out of this. So you can see that these are the magnets, and this is the coil of wire that can spin around. So as I spin, you can see that it lights up a little light. So I'm generating electricity. Woo. Exciting. Okay, so let's keep a truck in here. So if we look at the various ways to generate electricity, there's quite a few. And so we're going to look at some that are renewable today, and those are in the green boxes. So let's take a look at this first one. So we could spin the turbine with wind, we could spin the turbine with steam, or we could spin the turbine with water. Either one of these moving things, the moving wind, the moving steam, the moving water, can spin the turbine, which will rotate the generator, which will make electricity. We could also look at the 2 different ways to spin it with water. So we could use a hydroelectric dam, or we can use the movement of tides and waves to spin the water or to move the water. We could also burn stuff to make steam. So what do we burn? We could burn fossil fuels, coal, oil, and natural gas that you talked about with Ms. Fassler last time. Or you can burn biomass, things like wood or charcoal or biogas. Anything that's burning can be used to boil water to make steam. We could also use nuclear fission. Ms. Fassler will be talking about that next. So that fission process, creating a lot of heat that can boil the water to make the steam, to turn the turbine, to generate electricity with the generator. We could also do geothermal or concentrating solar thermal. So the ones in the green are the renewable ones that we're going to talk about today. And all of these spin the turbine to rotate the generator to make electricity. However, there's 2 down here that will make electricity without the use of the turbine or the generator, and that's solar photovoltaic cells and hydrogen fuel cells. So if you'll remember this screen and be able to, for each one of these energy sources, describe 2 things, really, 3 things: how it works, the pros, and the cons. That's the pattern you're going to see as we go through today. Some of these, ones that are involved with heat, can also be discussed in terms of cogeneration. So a geothermal power plant can have enough heat to generate steam to make electricity, but we could also use some of that heat to heat up buildings or homes nearby. So using one fuel source for multiple things like electricity and heating, that's called cogeneration. So if we look at the overall energy consumption globally, we see a big chunk of coal, big chunk of oil, big chunk of natural gas, some traditional biofuels, and then the renewables are way up here in a much smaller category. So this is overall energy. On the next slide, we're going to look at just how we produce electricity in the United States, and you'll see that crude oil is not represented there because crude oil, what we use that made predominantly for is transportation, so making gasoline, and then plastic products, making plastic products out of that crude oil. So now let's look at just in the United States. This is the electricity generated from selected fuels. And so we see coal, nuclear, natural gas, okay, kind of chunks there with the majority being natural gas. And then 38% are the renewables. And this is in 2050. If we look at 2020 where we are now, it's a lot less. But if we forecast into 2050, we see a much bigger increase in renewables. If we break down that category a little bit more specific, we see solar, wind, geothermal, hydroelectric, and then an other category, things like hydrogen fuel cells. So these are the ones that we're going to talk about today, but you can see that their influence are increasing, especially solar. All right, so what do we need to know with wind? We're going to start with wind, and this is going to be the pattern throughout the rest of today, is describe how it works, and then what are the environmental pros and cons of that source. So for wind, we're just going to talk about how we use wind turbines to generate electricity, and then the pros and cons. Wind is probably the easiest to understand because we basically are just spinning this turbine with the energy of the wind. So kinetic energy of the wind translates into mechanical energy in the turbine and the generator, and then that produces electrical energy out the other end. You may have seen small wind turbines, or you may have actually seen a field of wind turbines, like a wind farm, and the movement of the wind simply rotates the turbine, and that rotates the generator. So in terms of pros and cons, the pros is it's a renewable energy source, and it's also a clean source of energy. So at the point of generating electricity, there are no emissions. Cons, yes, there are some risks to birds and bats that might fly into the turbines. This is also specific to a certain location. Certain locations have higher winds than others, and also winds are an intermittent energy source. Sometimes the winds aren't blowing. Then we also have a con of habitat loss. Now, while the individual footprint of one wind turbine is rather small, the cumulative effect of a large wind farm would be a significant habitat loss. And then there's the aesthetics. Let's just imagine that I bought a house right here with the view of the mountains, and it's gorgeous and I really love it. And then in a couple years, someone built this wind farm in between my house and the view that I wanted. So that might kind of, I don't know, lower my property value, or I just might not get as much aesthetic pleasure from looking at the mountains. So we kind of have that NIMBY effect, not in my backyard. All right, so let's switch over to hydroelectric. So we are going to describe how electricity is generated from a hydroelectric dam. We'll look at the environmental impacts of those dams. We'll look at tidal energy, how we make electricity from tides. And so there's really three big categories of using moving water to generate electricity. The first one would be a dam. That's when we build up water behind the dam in a reservoir and then let it flow through to spin the turbine. Another one is just taking a small turbine and putting it directly into a river, a smaller river. And then finally, it's using those tides. But all three are using the moving water to spin a turbine, to spin a generator to make electricity. So let's start with the dam. So the dam is this solid kind of concrete wall built into a river, and the water behind is called the reservoir. So the reservoir builds up, and all of that pressure pushes water through the tube called a penstock, and it hits that turbine, which spins the generator, which makes electricity. But the word reservoir is an important vocabulary word to remember about dams because it's often used in explanations about the impacts of dams on the environment. All right, so one of the unique environmental consequences of building a dam is habitat fragmentation. So not just imagine that you're a little fish and all of a sudden you hit this dam. Well, now your habitat has been fragmented. You can't get to the rest of your habitat. This is particularly important for things like salmon, which spawn upriver. And then also habitat loss from the reservoir. So behind the dam, the water is now flooded what used to be terrestrial land, and that's been a habitat loss for those terrestrial species. But let's go back to the idea of the fish. If I'm a salmon trying to get past the dam, I can't anymore, and therefore I can't spawn and then the population of salmon would be greatly reduced. So one solution to that is called a salmon ladder. And a salmon ladder is a structure almost like a set of stairs to the side of the dam that water flows down, and the little salmon can jump up the salmon ladder to reach the reservoir. So just an interesting little fact about how you can kind of mitigate the effects of that fragmentation. A famous dam to know, not only do we have the Hoover Dam here in the United States, but the biggest one is the Three Gorges Dam in China on the Yangtze River. It is a huge electric power generation facility. So it's just a famous one that you may hear about. So let's look at some overall pros and cons of these hydroelectric dams. And this is the Hoover Dam, and you can see the built up reservoir behind it, and then the river below that, much smaller, less volume of water. So some pros: renewable energy source. There's no air pollution during operation. And then this reservoir also has some benefits in terms of economic and recreational benefit for fishing or irrigation. So there's some uses for this built up water back here. Cons: it's location specific. You have to have a river big enough and wide enough with enough power to do this. The habitat fragmentation and loss that we mentioned before. It's expensive. Okay, so it's expensive to construct. It may displace humans. So this happened significantly with the Three Gorges dams, because once that was built, the reservoir flooded places where humans had lived before, and those individuals were displaced. A unique environmental consequence of dams is also loss of downstream sediment. So I want you to imagine that the Hoover Dam was not there. As this river flows downward, it carries with it sediment and nutrients, silt, that will be deposited downstream and can enrich the soils with greater fertility, or it might deposit it into the ocean in terms of like a delta. So that sediment, which would normally flow downstream, is blocked by the dam. And so that has negative consequences downstream. It can also reduce the efficiency of the dam if it silts up too high and kind of blocks all that water being pushed through the dam. All right, so let's do a quick check for understanding here. So this question says, the Colorado River runs 1,450 miles from the headwaters of the Rocky Mountains to the Gulf of California. The river has many dams, aqueducts, and canals that divert water in order to supply water for electricity, irrigation, recreation, and domestic use. The question says, describe and discuss 2 environmental problems that are associated with water diversion. So let's take a look at this A first. So again, describe and discuss. There's 2 parts to this. So let's take a look at this person's response. One particular consequence of diversion is, such as in the case of the Hoover Dam, the prevalence of siltation upstream and the filling of the river with sediment which would otherwise be washed downstream. Eventually, it is believed water levels will be decreased upstream to such a point that both the hydroelectric power and the upstream freshwater ecosystem of Lake Mead will be greatly impeded. So there's a point right there, talking about that siltation that is going to affect what gets washed downstream. And then the person continues to say, water diversion also alters the lives of many organisms in the river ecosystem, such as spawning fish, which periodically travel upstream to lay their eggs of the next generation. Dams make such attempts to reproduce impossible. So there's 2 points there. So this one gets the description, this one gets the description and the discussion. All right, so here is the overall rubric. So talking about that loss of water volume or sediments downstream, or other ones that talk about the increase of water in the reservoir, things like flooding behind the reservoir. So again, points for description and points for discussion. All right, now let's go to tidal energy. Tidal energy is almost like an underwater wind turbine. So we're still extracting power from moving water. We're just doing it under the water as opposed to in a dam. And it benefits from these daily regular cycles of tides, but not all tides are equal. The tide here in Jacksonville, where I live, may be very different from the tide off the California coast or in another country. And clearly, we're not going to be using this in the middle of the United States. It's not around a coast. So let's take a look at a little video clip that talks about some of the details of tidal power.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
So this is the next little clip I'm going to show you is just a really unique tide. This is the Bay of Fundy in Canada, and it shows a really dramatic, really deep change in low tide versus high tide. In some places like where I live, the tide may be, I don't know, 20 or 30 feet that comes in, but it really doesn't change depth-wise that much. It just kind of water comes in and water comes out, and it's spread out over a really flat terrain like Florida's coasts. Whereas in this particular bay, the structure of the bay really does push the tide up really, really high, and it falls down really, really low. So just imagine the power that could be harnessed for tidal electrical generation. So you can see the low tide out there, and then you'll start to see it come in a second, people walking around, and there comes the tide. So that kind of a tide would be common maybe in a lot of beaches, but this all of a sudden becomes really, really, really deep. So all of that water coming in can turn a turbine, and then that same volume of water coming out could turn a turbine. So in places like the Bay of Fundy where there's big, big tidal changes, this type of energy would be useful. So let's look at some pros and cons. Clearly, again, it's a renewable energy source. There's no emissions during operation, and it's regular. The tides are going to come and go twice a day, and you can count on them. Cons, like we said before, it's location specific. There's probably some risk to marine species, just like the wind turbines are a risk for birds and bats. And as the little video clip said, the production times may not match the demand times. So where the high and low tides are going, that's when the electricity would be generated. But you may need electricity in between the tides, and that wouldn't work very well. Another way to generate electricity from flowing water is to simply put a small turbine and generator directly into flowing water. So as opposed to a dam, these just kind of go right into the water, the turbine spins, and that makes a generator rotate to make electricity. A lot of these are marketed for individuals who camp and hike or are outside a lot to charge up small devices. All right, let's do a quick check for understanding about hydroelectric power. So dams are built by humans for various purposes, including hydroelectric power generation and control of downstream flooding. Explain, keyword there, explain how electricity is generated at a hydroelectric dam. So let's look at this person's response. This person said, at a hydroelectric dam, Water passes over an impediment, which turns a turbine, which creates electricity. Well, there's 3 points available for this answer, and this individual gets 2 out of them. So they talked about the water moving, the flow of water, spinning a turbine, but then they just leave off the part of how the electricity is created through the generator. So 2 out of 3 points. Let's look at another student response. As the water is allowed to flow through the dam at a controlled rate, the water turns a turbine, which then runs an electric generator, thus producing electricity. So there's all 3 points. So again, if you see the word explain, you need to be sure that there's enough verbiage and detail to really explain what they're asking for. So here's the rubric for that. So there was 3 points of this. 1 point for talking about the movement of the water, 1 point for spinning the turbine, and 1 point for having the generator make the electricity. B, for this same question, says identify 2 economic factors other than hydroelectric power generation and control of downstream flooding associated with dams. So this student said the dam provides an area for recreational activity such as fishing and jet skiing, which brings in revenue to that society. People go to the dam and pay to do different water sports, thus helping the economy. Boom, there's a point right there. They really explained what that economic benefit was. The second one says the dam also provides jobs during the construction of the dam and then afterwards the running of the dam, therefore lowering unemployment rates and helping the economy. Boom, there's another economic benefit. So this person gets 2 out of 2 points. Let's look at this one. Dams such as the Hoover Dam are tourist attractions and tourism generates money for the surrounding businesses. Boom, there's that same point about tourism and recreation. Then they go on to say using water to generate power is also cheaper than having to drill, refine, and transport oil. Well, this only gets 1 out of 2 points because the second thing they talked about, the generation of power, is exactly what the question did not want, other than hydroelectric power generation. So again, be sure when you're reading your questions, read them slowly and carefully and pay attention to these clauses that may direct your answers to include something other than something else. So here's the possible answers for that. You could have said recreation or tourism, jobs. You could have said using the water for things like irrigation of fields, commercial fisheries, or commercial shipping. All right, so let's shift to solar energy. So to do this, we are going to first describe the difference between active and passive solar energy systems. Then we're going to look at solar photovoltaic cells. Then we'll look at the pros and cons again. All right, so let's start with passive versus active. These are just 2 broad categories that are really easy to distinguish. If you have no mechanical or electrical devices, you're looking at passive. So passive solar energy systems absorb heat directly from the sun without the use of mechanical and electrical equipment, and energy cannot be collected or stored. As opposed to the exact opposite of that, which is active, where we are using mechanical and electrical equipment to collect and store the energy from the sun. All right, so we'll go into each of these and give some examples. So let's do solar or passive solar first. So this is, again, no mechanical or electrical devices. And this would be something like passive solar heating, types of designs of buildings. So for example, if I want to reduce the amount of heat in my house, maybe I plant a large tree to shade my house to reduce the heat. Or maybe if I want more heat in my house, I build southern facing windows, especially if I'm in the northern hemisphere. So a southern facing window that would collect all of this heat, and then maybe some cement floors down here that will kind of not store some of that heat, but will radiate the heat back into the house. Almost like a greenhouse effect. You're using that idea of heat coming in passively through something. Or you could think about like a solar cooker, using all the sun's energy focused through mirrors all into one little place right here where you could boil water or cook some food. But again, you are not using any mechanical or electrical devices, and you are capturing the heat from the sun. So here's another example of active solar heating now. So it's another example of heating, but now we're going active. So this is an example of a collector on the roof. please do not confuse this with solar photovoltaic cells. This is not a solar panel that you might be more familiar with. This is almost like a giant mat that sits up on the roof, and inside are all these little coiled pipes that water flows through. And as that water flows through, the heat from the sun will heat up the water. So cold water comes in, runs through all these little pipes on the roof of the house, and it ends up being a lot hotter. And then that hot water can be used in the house for different things. Or you might be able to use it to heat a pool, for example. So you might have cold water from your pool going up onto the roof and then moving through these little pipes, being pumped through, getting hot, and then coming back into the pool. So same system here, the hot water coming to the house can be used for appliances, or you could even transport it through the floor and heat the floor. But again, this is not about generating electricity. This is about actively pumping heat into your house that's been captured from the sun. So now let's make some electricity. So this is another form of active solar. So this is a situation where I have a large tower. So here's our large tower. And at the top, there is a liquid. These thousands and thousands of mirrors that are out into this open desert area are all pointed directly at this tower. So each mirror is reflecting sunlight into that one location. And that obviously is going to be a huge temperature increase that can be used to boil a liquid, to generate steam, to turn the turbine, to turn the generator, to make electricity. And also because we're making heat, perhaps we could use some of that heat to heat buildings or do other things with, so it might be a source of cogeneration of electricity and heat. All right, so now let's go with what you're probably more familiar with, solar photovoltaic cells, or just PV or solar PV. This is about light. This is not about heat like the other things. And this is when we have these semiconductors within the panel. And as soon as they're hit by the light, they release the electrons, and those electrons begin to flow, and then we have electricity. And it can be on small scale, like even your solar calculator, or it might be a solar panel on your roof, or it might be a set of solar panels in a big field that's really large scale. But no matter which scale it is, we're not spinning a generator to make electricity. The electricity comes from the semiconductors in there that when light strikes it, moves the electrons around. So let's take a look at solar.
Solar PV. Solar photovoltaic cells, or as it is commonly referred to, solar PV, is a technology that converts the sun's energy into direct current electricity by using semiconductors. When the sun hits the semiconductor within the PV cell, electrons are freed and form an electric current. There are various semiconductor materials, the most mainstream being crystalline silicon. But other materials are being tested to increase the efficiency of converting sunlight into electricity. Unlike solar thermal technologies, solar PV can only use direct sunlight, which means when the sun doesn't shine, electricity isn't produced. One of solar PV's major advantages is that it transitions electricity generation from big, centralized facilities to smaller, decentralized production sites, like the roof of your house. This turns energy consumers into so-called prosumers, people that produce and consume their own electricity. Another advantage is that solar PV utilizes the most abundant renewable resource on Earth. Estimates show that there is 10,000 times more solar energy coming to the Earth's surface than our global annual fossil fuel demand. Traditionally, concerns about solar PV were about cost, intermittency, and efficiency. But large-scale implementation and rapid cost declines have surfaced more complex issues such as grid compatibility, lack of solar industry expertise, and the use of rare and precious metals that make up the cells. That's solar PV.
So let's look at some overall pros and cons. The pros should be pretty evident. It's a renewable energy source, and there's no air pollution or waste during operation. Some of the cons, well, it's an intermittent energy source. If the sun's not shining, there's no electricity. There could be some habitat loss or habitat fragmentation from these large solar fields. And then there's also significant cost involved. This has not yet come down to a point where it's as competitive cost-wise as some of the other electricity generating sources. And then we also have to think about how we're mining and extracting the elements and the materials needed to construct the panel. All right, let's do a quick check for understanding about solar. So this question says, upon receiving notice from their electric utility that customers with solar power systems are permitted to sell excess power back to the utility, an Arizona family is considering the purchase of a photovoltaic solar energy system for their 2,700 square foot suburban home. The initial costs of the systems they are considering range from $7,000 to $3,000. A says, describe one environmental benefit and one environmental cost of photovoltaic. So here's where you just do your pros and cons, but be sure that it's environmental and not economic. So the first person says, photovoltaic power systems are environmentally beneficial because they release no harmful pollutants or emissions. Let's stop right there. If the person had stopped right there, they would not have received the point because it's talking about generic pollutants or emissions. But they get the point because they say, like carbon dioxide, sulfur, or ozone into the atmosphere. So there's 1 point for a benefit. There's no harmful emissions or pollutants. Then they go on to say an environmental cost of photovoltaic systems is that they require large amounts of open land to generate ample amounts of energy and therefore may result in the clearing of a forest or natural habitat. Boom, there's the other point. So the official scoring guide for this, you could have talked about any of these environmental benefits that really do contrast them with other energy sources, like there's no nuclear waste like you would find at a nuclear power plant, those kind of things. And then in terms of the cost, the negative to the environment was a lot about how they were manufactured, that you'd have to use water or other resources to build the solar panels. And then there's issues with the infrastructure for the commercial use of the photovoltaic systems. So yeah, 1 point for environmental benefit, 1 point for cost. D says, I'm jumping around a little bit on this question. D says, describe 2 ways that the homeowners could use passive solar designs and or systems, and for each way, explain how it would reduce the homeowner's energy costs. So there's 2 things you have to do here. You have to describe a passive solar energy design and then explain how it would reduce costs. So let's take a look at a student sample. Homeowners who live in the Southwest can build homes with windows facing the northeast to help keep their homes cool from the sun. This would reduce the homeowner's cooling costs because they wouldn't have the sun blasting its heat into the homes during the hottest time of the day. Good. There's a description of what they would do design-wise to the house, and then the other point coming from how it would lower their cost. Then they go on to say homeowners could lower their thermostats during the winter and wear more layers of clothing to stay warm and reduce energy costs. They would reduce the cost by using the thermostat less and therefore using less energy. While that is true, it gets no points because that's more of a behavior change and not a design or a system that they've installed into the house. So again, there's lots of possible solutions here in terms of design elements, in terms of skylights or overhangs or window treatments, but it had to be something that you would design or built into your house, not a behavior. All right, let's switch over to geothermal. Geothermal, again, we're going to describe its use and then its pros and cons. So to do that, we will describe how we generate electricity from geothermal and then look at pros and cons. So same patterns again. So in a nutshell, geothermal power plants are using the heat from the earth, deep inside the earth. So we are drawing up really, really hot water from deep in the ground that we can then use to spin the turbine. That steam spins the turbine that moves the generator, which makes electricity. And then we can re-inject that cooler water down into the ground again. But it's the source of the heat is not coming from us burning something or the sun or anything. It's coming from inside the earth. So let's take a look at an example of that.
Geothermal wells are drilled into the Earth's crust at approximately a depth of 3 to 10 kilometers. The heat is extracted with a variety of methods, but in most cases is drawn from the earth using water and steam. Hot water from the earth may be directly extracted to heat homes and buildings. This is done either by directly circulating the hot water through buildings or by pumping it through a heat exchanger that transfers the heat to the building. Geothermal heat can also be used to produce electricity in a geothermal power plant. Electricity is generated when geothermal heat produces steam that turns turbines on a generator. The major regions of geothermal development are in the most volcanically and tectonically active regions of the world. Though geothermal energy is currently a small player in the world's energy mix, one of its key advantages is its reliability and consistent power generation, which means it can provide baseload electricity. Concerns with geothermal include the accidental release of CO2 and hydrogen sulfide emissions stored in the Earth's groundwater that is often used to carry geothermal heat to the Earth's surface. Additionally, drawing heat from the Earth's crust can, if done irresponsibly, lower the ground temperature below the surface. The upfront costs for geothermal energy production are relatively high. It is expensive to carry out the seismic sensing, test well drilling, confirmation testing, and other necessary preliminary investigations to ensure that your new geothermal plant will be capable of meeting desired production. That's geothermal.
So just like it said in the little clip, the areas that are most likely to use geothermal energy are those places that are have lots of tectonic or volcanic activity. So we can see here, this is the Ring of Fire, and there's some of the other fault lines. But one of the most unique places is Iceland. Iceland gets almost every bit of electricity from a renewable resource. So about 75% come from hydroelectric dams, and 25 of that is geothermal because they're located right there on that plate boundary. So here's a funny little clip of the benefits of the geothermal power in Iceland.
Hi, I'm Guðrún. Welcome to Iceland Academy. You know, Icelandic nature isn't just amazingly pretty. It's powerful too! Geothermal power makes the land of ice hot and buzzing, since it creates heating for around 9 out of 10 houses and almost 30% of all our electricity. The other 70% is also created by natural forces such as water and wind. For over 100 years, we have used this natural power to generate clean energy, to heat our homes. And that's why Icelandic homes are so warm in every way. We don't mean to brag, but we gave up domestic heating with dirty coals and oil way before it was cool. It's also essential to grow our year-round vegetables in geothermal greenhouses. I mean, you didn't really expect these juicy tomatoes to grow wild right between the geysers and glaciers. The natural power also inspires numerous innovative companies in various fields of work, such as genetics and health-related tourism. The energy even gives us a chance to get up close to wildlife at its biggest. And it's even more special on a silent boat powered by electricity from renewable sources like waterfalls and hot steam. And last but not least, it warms our geothermal pools. And with great power comes great responsibility. To enjoy it. Skål!
So clearly Iceland is enjoying their geothermal, and not every place in the United States has the same capacity for geothermal energy to be used. You can see that there's more geothermal resources in the western part of our country. So overall, some pros and cons. It's renewable energy source, clearly, and during normal operations, there's no carbon emissions. It's really reliable and consistent. You know, the Earth is still hot, it's gonna be hot. Some of the cons, again, very location specific. Very expensive upfront to construct, and you do have the unintended consequence of some leaking of hydrogen sulfide into the atmosphere. All right, so we're going to end with hydrogen fuel cells. And again, the pattern is, how does it work? Pros and cons. So to get there, we're going to describe how it works. Look at the pros and cons. So as a brief overview, this is what a hydrogen fuel cell looks like. You have an anode and a cathode. And in between, you have an electrolyte membrane. The fuel for hydrogen fuel cell is obviously hydrogen. So you're going to put hydrogen as your fuel into the fuel cell. What's going to happen? This anode is going to split that hydrogen into protons and electrons. It's going to send the protons through the membrane, but it's going to put the electrons on a very different path. And in that little circuit that they travel through, that movement of the electrons, there's your electricity generation. And the really brilliant part of a hydrogen fuel cell is that the only waste products are a little bit of heat and some water. I mean, that's just brilliant. If we could really tap into hydrogen fuel cells, think about how environmentally sustainable that would be. So let's take a little quick look at their clip.
Hydrogen can also be used for electricity production through a fuel cell. A fuel cell is an electrochemical cell which produces electricity by converting chemical energy into electrical energy. When hydrogen is combined with oxygen in a fuel cell, it produces heat and electricity with only water vapor as a byproduct. Fuel cells are unique in terms of the variety of their potential applications. They can provide energy for systems as large as a utility power station and as small as a laptop computer. Fuel cells can provide electric motor transportation for vehicles and provide power in stationary and portable power applications. Fuel cells have no emissions at the point of operation. The most significant advantage of hydrogen is that it is an efficient energy carrier. However, the ultimate challenge with hydrogen is getting it in its pure form. While some of its applications appear attractive for environmental reasons, deriving hydrogen requires energy that can result in greenhouse gas emissions and air pollutants that lessen the overall environmental benefits of the technology.
So let's just repeat that again. So while the hydrogen fuel cell itself, as a way of generating electricity, is brilliantly clean, the problem becomes, where do we get that hydrogen gas from?
In addition, cost and practicality.
So here's an example of there's some buses in London that run on hydrogen fuel cells, and there's several examples of this around the world at different scales. This is just one that I'm familiar with. But when we look at the pros and cons, again, pros and cons, there's no emissions, it's very efficient. But the cons, like I said before, where do we get this hydrogen gas from? So one way we can produce hydrogen gas is through electrolysis of water, but that requires energy in and of itself to create the hydrogen gas. And then if we're getting the energy to do that from a fossil fuel, well, then how, clean is this energy source of hydrogen fuel cell? And then we just need some way to distribute this to customers. Just to, think about how you put gas in your car. There's a gas station everywhere, and there's pipelines and trucks. There's infrastructure to bring that gasoline to you. We don't have that yet for hydrogen. But the biggest part is this: where do we get the hydrogen gas from? We can make it, but a lot of times making it requires us to use fossil fuels to get electricity to make that hydrogen gas. All right, let's do a quick check for understanding. So which of the following is a true statement about passive solar heating? So you should have picked B. It's part of the kind of related to the greenhouse effect. And remember, passive solar heating is no mechanical or electrical equipment. And again, we're talking about heating, not generating electricity. Let's look at one more. Which of the following energy sources is not derived directly or indirectly from solar energy? So this one might be a little tricky one, but the answer is geothermal. So geothermal obviously is not directly or indirectly related to solar energy. Photovoltaic is, but you may think, well, how is hydroelectric or biomass or wind? Well, yeah, the water cycle is powered by the sun. Biomass, that's living things. Photosynthesis, the sun. And then the unequal heating of the earth is causing wind currents. So everything is directly or indirectly related to sun except geothermal. All right, so where did we go today? We talked about solar, hydroelectric, geothermal, hydrogen fuel cell, and wind. And for each one, how does it work? Pros and cons. And then we also practiced several times being able to describe and explain some of these concepts. So again, I love this little diagram. It helps me to remember everything all in one spot about how the different ways we can produce electricity. All right, so your homework for tonight is this question. So this question starts with a graph, and let's just kind of deconstruct the graph a little bit before we leave today. So the first thing you need to do when you see a graph is slow down, look at the pieces of the parts, find out what's going on, and then figure out what story it's trying to tell. I like to start with the axes. So on the y-axis here, it says GDP per capita US dollars. So we're looking at the gross domestic product per capita, per person, right? So we're talking about income here, how much money the average individual person is making, kind of. And then if we look at the x-axis, annual electrical energy consumption per capita, kilowatt hours, kWh. Although this year's exam, the 2020 exam, will not have you do calculations, you still need to be able to understand and interpret quantitative data. So while you may not be asked to calculate, kilowatt hours, you still should be familiar with what that unit means and how to understand it in context of a graph or a chart or a table. So we've got electricity consumption here and income here. And then it asks you for a few questions. It is going to ask you to do some description and some explaining. So remember, those two task verbs mean something and they should dictate or influence your writing. I do want to make one modification though. Part D gives you an option of choosing either sugarcane or tar sands. I would like you, for the purpose of homework, to just pick the tar sands because that's something that Ms. Fassler talked about last time, and she will go over the answers to this next time. So thanks again, apes. Hope you're having a good day. Hope you have a good afternoon, and I'll see you next time.